Hi, my name is Briana, and my project for this semester was dealing with fair work and credit distribution, specifically for undergraduate student groups working on a assignment for a class. So first, we'll look at the problem sort of as an introduction to it, and then the formulation, kind of go through the two algorithms that were used, and finally come to some conclusions and continued work. The goal of this project was to fairly distribute work and appropriately assign credit to participants. And so, a best case scenario would result in an envy-free solution, and that's a solution where participants feel as if they've gotten a fair share. So, this problem was broken up into two separate fair division problems. The first was a division of the work, followed by an assigning of credit for the amount of work each student did. And so the lone divider method could be used to divide the work, and the credit was then distributed sort of proportionally to that, where the amount of credit you receive, say 100%, aligns to the final grade you would receive for the project. So if the group as a whole received 98% on the project, then students who received 100% credit would receive the entire 98%. Another note is there was no way to receive more than the final grade that the group as a whole received. So, fair work distribution, how's the lone divider method done? So, one student is randomly chosen and they divide the work into what they believe to be equal sections. And then from those sections, the remainder of students choose which portions of the work they want to do, and the divider receives whatever is left over. And this typically results in an envy free solution for the work distribution. So then how is the credit distributed? And so there's kind of two cases and then some sub cases. So in the first case, the easiest case, everyone does the amount of work that was agreed upon in the work distribution. And when that's the case, the credit is evenly distributed among all students, meaning that everybody receives 100% credit, everybody receives the same final grade that they earned. The second case becomes much more complex when someone doesn't do their allotted amount of work and someone else has to step in and does extra work. That means that the work distribution is changed. And so the amount of credit that one person, the person who did the extra work, if there was only one person who did it, would receive 100%, and then everyone else would receive a lower grade. And that is not just the person who slacked on the work, but everyone who also didn't pick up the slack. So then a little bit more about how that would work is that in the original work distribution, everybody does um, their fair portion of the work. And so if all of the students pick up the extra slack, then the new distribution is that student A did only a half of their allotted work, and then all the other students did 1 over the number of students squared amount of work. And so all of those students would receive 100% of the final credit. They all did the same amount of portion. They all picked up the slack, whereas student A would lose 1 over 2n percent of the credit. So what are some of the conclusions? The lone divider method generally gives an envy-free solution to the work distribution, which means that the credit distribution will also be 100%, will also be envy free. So then something that I'd like to take minutes to note is that if I had not separated these into two separate problems, being work distribution and then credit attribution, then more classical compensation methods of fair division could have been used to solve this problem, but that would result in a much more complex problem. So some of the continued work would be to look in how trust or lack of trust in group members might affect the work distribution, and then maybe run a simulation or study of how often these algorithms actually produce MV free solutions in practice. Thanks for listening and have a great day.